Hello, I'm Michel Combs from blockSmith. I'm your digital locksmith and protect your data. So what we do at blockSmith, we make password unbreakable. So we know how to keep secret. Our method is simple. We take basically a theorem from Gabriel Cramer that dated from the 1750, and it says that to find a solution of a problem with n unknown, you need n equation, n clues to be able to determine the n unknown. So we apply this to authentication. Do you know the 2FA, MFA, multiple factor authentication? Basically, we have multiple secrets to be able to authentify yourself. Well, we use the fact that if you have n equation, that would mean n public known value that are derived from those secrets. Like if you have n files, like if you have n public keys, well, we make it n plus 1 factor, so that you always missing one to resolve, to make the problem solvable. And so any hacker will have undetermined problems, meaning that there will be one infinity of solution to solving, finding the n plus n secret or n plus 1 secret that fulfill the equation, the n equations, the n output, the n public values that they have at their disposal. And so if you keep always one secret more, one private key more than all your public keys, you're safe. It's a mathematically unsolvable problem. So that's how we do. And so what we keep as multi-factors, we mix something that you have, that will be a seed, a card, a dongle, a file, a private key, and we mix that with what you know. And so that will be an authentication token, like a password, passphrase, anything that you remember. And so if we keep those two private data in a number that is above the public data, and public data that can be any file that you encrypt, any hash that is stored up there in the wild, any public keys, everything that give a clue about your private key, basically. So let's do a little example, and we will do Go coding, and let's have something that will guarantee that you have n plus 1 secrets. So we will make a little program to trade secret, for instance, to trade keys, and we'll see how this can apply. So let's go into coding. Here you go. So I have a little template that I like to have. Let me move my screen so that I get it there. Yes, here you go. Let's call that program trade key. And what we want is we want to get as an input a token, an authentication, like a password. And we will trade that password for a key. So I need, for one key, you will need two factors. And so that means, let's get it on. So I always start programming with specifying an intent. So my intent is, it's not visible the comment. Let's change colors. It doesn't work. I don't have my change color mechanism. Oh shoot. Okay, let's pick a color that looks better. This one? Yeah, maybe that one is okay. At least they are more readable, all the comments. So, and then securely trade keys. So that can be like a password manager. So where we can have where each key has a key ID to recall the key. So the trading will be 2 MFA for one key. So it's like a password authentication where you enter a password to unlock the password authentication password manager. You unlock the manager with one password, and there is somewhere a key that is reside on the computer, on the device, something you have, something here, and then that means for each key you need to have those two factors. And so what we can do is that we can have a password per key plus the something you have. It's okay if you combine those two. It's okay to reuse the same thing you have for the password manager, because combine would make it a unique key. So that means there is no reuse of key, like a reuse of password. That's if you use like on the website, you use the same password everywhere. You have a reuse problem that can make your account more prone to attack. Okay, so that's our intent. Oh, input the intent above. That's okay. Now, let's load down some environments. So usually I have a begin to load everything before runtime. And so I want to have a file that is called environment or startup, or so RC. And so I put a environment variable that contains the name of files, and I will load that down the road. So what else do we have? Let's move that up, that I want to be able to read the things and can have a version. Let's say 0.0. Let's start. Usually what I do also is some debug thing. So my sub debug. So for now I just put placeholder. Oh no, let's do it. So I want to print something formatted. With a number in front of it. So I will use a L. Oh, that's a count. Count plus plus. So I shift the format. So I take the format and I do printf on standard error with the number of count first, and that's it. So that you can have a debugging, at least methods. Then also that's it for now. Let's put a registry for the key. So that will be our database registry where all our keys are registered. And let's load that from a file registry.yaml, YAML format is okay, and then for that, so if the file is there, we will load it, and so registry equals load file at registry.yaml, and I need to declare the load file. So load file will be use, I click below, oh, something disappear, use YAML access qvw and say load file, and I bet I will need to have the damn file to save it back. There you go. And so registry load files, else I can put the default value registry equals tag, and let's put a key, my key called Michel, and that will be with a value. With a value I will call UUID. Let's all have the keys in 128 bits, and we can do UUID version 4, which is a random UUID, and that's it for now. Just get one key. So those are in a file. Doesn't need to be private because it will be public values. It will be access key. So now, what we want to get as the file we want to get a key ID as an input. And with that key ID, so if there is a key ID that is passed as an input, then we can call the trade methods. If key ID, and if there is a value in the registry of key ID, so there is an entry of key ID, then what we do get the key, my key equals we get the method. Let's call it trade key, and it will receive key ID. And maybe some versioning, like if we rotate the keys, so with a counter. So it's like you, and then we can do how do you call it? You can, let's start to 0, and you can do one time keys by changing the counters. So it's like a CNC act as a hash-based OTP. So now let's write the methods, or we can do an else case. Else case, that means if it doesn't exist, then that means that either we didn't give a key ID, so we have to generate one, or the key is not in the registry, so we have to register. And so we can say my key equals register key, and we pass the key ID, something like that. Okay, I have a default method here where the import is so that if we use that as a package, like we did somewhere, package trade key, then allow you to export the function, the methods that are in that package. So now let's write the methods. So trade key sub trade key that will take. So like I say, there is option. So let's see if let's pass that in the first place. If there is option at the end, that means we say pop, then we get into the option, and so it's only if it's a hash. So if it's a hash, like mean the last argument, so the -1 in the underscore variable, and so if the reference of that is a hash equals hash, then pop that value. The argument, so let's see the argument. So an example, my key equals trade key. We can take the example that we had above, basically. Key ID, and we don't have to well, we can even have the counters, like also without the options, something like that, like 2 arguments. And so that means we can do key ID shift, and let's set a default value from the options if there is an option that is present. So the key value default will be key ID from the options. And now we want to have the C counter, which will be the last parameter, or the one, let's see if it's not defined, the one from counter, the optional counter. Okay, now what we need is the 2 factors. So let's get a token. That will be from an authentication method, get auth, and we can have a prompt password for the key ID for the key represented by key ID. So let's say for key ID's key. There you go. So now we have the token, then we can print the token. So the token is this will be private. So let's have a method rather than debug. Well, we can start with debug. Debug auth token equals colon the token. So for now it's unsafe, but let's put unsafe. So be sure that we come back that later. And so we get a token. So let's work on the get authentication, and I need to continue that later. Let's put numbers line. And the method for authentication. The method for authentication is simple. We will prompt the user for a password. So one argument, well, we can have formatted, yes, we have formatted prompts. So that means we have to build the prompt string. Prompt equals, so as printf, and so we shift the format string, and then we apply that to all the arguments, the other arguments. And we can use ask pass program. There will be, there is one ask program that is super interesting, is the bin systemd ask password. The reason why it's interesting is that this program, first it's focusing the keyboard. It's also not in the process memory, it's in the kernel zone. And so that makes an area that is protected for memory leak. At least you need to have a very, very special privilege to be able to to spy on the kernel pass string. So this is used usually for decrypted disk drive at boot time, for asking for the credential for that. And so if we use that as password, then it will be safe. So there is options for that. And so let's prepare an option string, and there will be. So an ID of the request. So trade key password. So that's the name of the request. Then we want to store the key name somewhere so that we can cache it, and that will be trade. So that's the key for the key ID. So we can place the key ID there. Keys, and so we put sprintf then. Sprintf. And we want to cache that. So we say accept cached as an option. What else? What we need, maybe a timeout, 3-minute timeout. Minutes is 180 seconds, and we say we want to so get out passwords thing. So this one is the second argument, so we can pass that as _1, no 0, because we have made a shift already. Ah, there you go. Now we can execute the aspass command. So we will use a system or exec. We can do open, because so that we get the output. So let's do an exec file handle, and we print the command. So that will be the aspass, the option, and the prompt, and we pipe that the output to us. And so we do ask pass the option and the prompt. There you go. Do we have an error because it's all green? Yes. There you go. Now we get the output, and we will chop that, so I remove the line return, and we will call that key 32, because I would like to have it in base 32 format, which is usual for OTP seeds. And we get exec. So that one is chop, and then we can close the exec. And now the key is decode base 32. Okay, so 32A is a special decode for me that I already written. And the key 32, and that's where I need to use the library, but I get it as library mix decode base 32A. Okay, there you go. Now, what else? We just return the key. The other thing is that we can also test if the key is secure. So that means if people type a wrong password, like something that is in the dark web, something that is pawned, and so that's usually like to validate the keys or the password. And so we can do a hash of, so like the SHA of that key. So SHA for secure hash algorithm. SHA the key. So we want the SHA in, so that will be, let's do a key hash. I make a routine for the hash and call SHA. I usually do that so that I can switch algorithm if I want. SHA1 for now, and key. And so let's write so let me do dot for taking that later, and sub key hash for key hash, and in that I want to use simply the crypt digest. And so I think I have that somewhere, so let me copy paste it to go faster. There you go. So I use script digest, I shift the algorithm, I join all the data. Well, this is not mandatory here because we can also, well, it's because I delete it right away. So that's any information that are sensitive are not present in the memory. So, well, I'll delete the 0 they're supposed to be. Let's do an example. My hash equals k hash. So we need the algorithm name, SHA-256 for instance here, and a secret, and the any type of entropy or key or message. So that's why it's a keyed hash, because you mix one key with something that can be public, and that's why we delete the 0 version. 0 is the first argument. So we add to the data, to the digest, and then we return the hash. Okay, so now that is that. Or maybe we want it to have it in hexadecimal. So unpack that into X format. There you go. Now we want to split that SHA into pieces and then do verification if it exists online. And so I do have, I think, a procedure that do that, and that gets, so prefix equals substring. Let's do the first 5 characters of the SHA 0, 5, and we send that to pawn.org. Let me pull the library that I've made. Yeah. Did I just... No, click on the wrong one. So the point version, yeah, here you go, the prefix. So I get the char. No, I compute the char also, I don't need it. For prefix, yeah. But that's what I need. I just want to have the point. I take the char as an input, take the 5 first characters, and send it to this API endpoint. And at the end, it will return the prefix that we computed, the number of hits, that means number of how many times it has been found, and what are the suffixes that have been found, and list of the matching suffixes. Okay, so we go back here, and instead of prefix, what we can do is we can call the pawn, so prefix hit and the matching suffix, so the number of match. No, it's the range. Yeah, the number in the range. I don't know what's number. KN.
Solar files from 1105 UTC.
For K anonymous number. Okay, K anonymous. And here we do pond, and the values of the char. Simply as that. And then we can print that with the debug utility that we had on the top. And so we want to print, so this is the authentication function, and we want to print the key. And back key. We might want to print its length so that if it's too short, then we can complain. Length key. And we want to print the number of hits. That is important to know if it's safe or not safe. And so the key, the number of characters the key has, and number of hits.
Building solar video clip.
There you go. And we want to return the key. Let's test that. I need to declare the point, but I think it's here. No, it's not there. So let's go on top. Use. Let's open a terminal. Let's move it to the right and do a Perl Perl thread key. Uh-oh, can't locate. Yes, because it's in the library. And so use lib of Radiant lib. Radiant is a set of technology that we deploy that are conscious certified, meaning they are doing no harm and even regenerative for the humanity. So if I run that again, and if I'm the trade key, yes, registry, because we don't have made the register key yet. So let's do so trade key, and even the dot dot will make an error, obviously. And we can put, that's funny, didn't I get them? And sub, let's do a placeholder, right? Register key. Because we have no, why we have no key defined yet, huh? No, there is a Michel one. Yeah. Because he didn't place it in arguments. Okay. So I need an argument. As my only registry entry is registry, not registry, is Michel. So if I do thread key Michel, so I want to thread the key Michel. Is it working right away? No. What's the problem? So shift key is there, and there's no debug things because thread key. If defined key, register key, yes, thread key counts, so you should enter that. Let's do debug key ID, just verify that we are at the right place. Key ID, it's not token, it's token. How come? Tell my debug routine. Yes, my debug routine is here. Oh, I know, I might have registry file. Yes. There you go. So it asks me password for Michel key. And so I type it, let's say 1, 2, 3, 4, 5. So the nice thing about this thing is that you can use really dumb password because they will be converted into key with other factors. So that means it's like having a one-time seed that generates all your password, and so it's still safe. So what is it doing? I enter the password. There you go. And it says authentication is the yes. So that's the base 32 version of my password. So it's 3 characters that does not exist because yes, it's binary password. So it's good. Yeah, that's what I say is that if you combine, if you derive from a simple password a complex one, and then you don't give up the recipe of how you derived, that means you keep one secret, then it's totally fine. And so the token is very short. It's like f to the power 3. So that's the value that is returned by typing 1234 as a password. Uh, and so yes, we do have a token. So this is sensitive information because if you have that, you get everything. And so we want to protect that. I have a safe uh, routine from the my environment module. So let's edit that. Environment PM and sub safe. It's not there? Why is it? Let's open another terminal. Can I close that window without the terminal? Yes.
Starting solar downloads.
So with that terminal, cd radiant lib lib, and we go look for sub safe. Oh, it's important. Yeah, I guess it makes sense. So it's simple. It prints the SHA of the key and add an emoji also corresponding to the prefix that we compute. So that means that you never give a full version of the hash. You have a restriction of the hash, a small substring, like 5 characters, so that you have enough collision so that people cannot guess your key. And so that's how we do keep things safe. And so let's move to, where was it? Yeah. So I want to get that one. So that's the second debug token. Well, token, we should not print it. But here, let's put it safe. And call it safe here. And token 2 for now. Yeah, for now it's okay. So this one is safe. Wow, we can. Do a safe token too. So password 1234. There you go. So the password is 0 hit. It's a 2 char. Well, did I make it 1, 2, 3, 4, 5 the other way? Yeah, maybe. So yes. Why my key ID is protected? Did I say key ID safe?
Protecting solar files from 1119 UTC.
Token key ID is you can display the key ID. There's no problem. It's the first 5 characters. Yeah, key ID. No, that was Michel. So the odd token is this one. The odd one is this here. There you go. Here. And the 2 character and no it. And the token itself. Here you go. So that's the little symbol for the token, and this is Fox for the password. Okay, perfect. Next. So we get an authentication token. With that, we want to combine it with the key ID. But we want to have a secret environment variable first.
Building solar video clip.
We keep the n+1 secret. So we call that announce, meaning something we use only once. Announce once. That will be from the environment, and we call it trade key seed. So we get the trade key seed from the environment, and if it does not exist, we can get a default value. That would be unsafe, but is to keep the hacker entertained. The idea is that if you get the wrong value, you still have working programs, and so you don't see the difference between a working key and a non-working key. So I always get default value that are functional. You can only recognize them, but that's it. So now we get so we want to have generate a key from the token, from a secret seed, and from the key ID, obviously. So key ID, token, secret seed. And what we want even is generate a key to encrypt that secret into a string that only the token will yield decrypt. So we get a data protection key that will be a hash. So I'm generating an encryption key for the secret, and that will be a hash. So k hash. Let's put a SHA to 56. And I say we use the secret seed. Then we use the token, and we can add anything we want to that. I mean, to make it more unique and non-guessable. And so we can even add the version of the software and the counter if we have the counter, remember? There you go. And then if we add the argument, like if you have plenty of argument there, we can even add those into the hash so that we can later improve the security of that by adding secrets to that list. And so we put all the argument there. So here it is. So that's the encryption key. So we can do a debug data protection key equals, and same thing, we need, it's a private thing, so we display it safely. Data protection key. There you go. And let's see. Let's try it. Do you make a mistake? Yes, probably, because yeah, I have the double quotes. Let's remove those quotes. So password 12345. So that give me a pronunciation key of that prefix. Which is that? And so yeah, not bad. So what I can do is I can display to you this time so that you will. So if I'm at the terminal, I'm on TTY, then I will display it unsafely. And so probably we want to encode that
UT 2067 done
in hexadecimal, or even I probably have a encode. No, that's okay. Unpack. Let's even do the opposite. That I want to have it safe on the terminal and unsafe. I mean, well, yeah, unsafe. If it's something that on the terminal, like a pipe or type of thing. And so now so this is the same thing, and if I do pipe cat, here you go, I got the secret key here. So you see, with 1, 2, 3, 4, I generate something like that, and it's based on the token that is the 1, 2, 3, 4 that has the 1, 2, 3, 4. The nonce that is a trade secret key that is not even this one because it's coming from the environment. And so that means if I change the key ID, I will have a different one, and it's totally not guessable. It's 256 bits. This one, it's 256 bits of pure entropy, so it's nice. And now I need to use that to encrypt. The secret. So we want to encrypt our password, like 1, 2, 3 type of thing. So to encrypt our password, we simply do a XOR, because it's random. So that means it's totally okay if we do one time XOR key. So my secret equals just a plain XOR function of what's in the registry, . registry under the name key ID. And we decrypt that with the data key, data protection key. And so this way, every value in the registry above here, this one, are secret ciphertext that are decrypted with that key that is generated with the sample password. And so I can have return secret. And let's write down the XOR function, a very simple one. Sub plain XOR that will take 2 arguments. And so we do a for each. To value A and B, so we
Starting
want
solar downloads.
2 arrays and pack. Let's unpack 64-bit by 64-bit. And we do XOR. So we want to save the result into a XOR array X. So we do XOR chunk by chunk because then the CPU can be more useful, 64-bit by 64-bit. So that means Xi will be AI XOR BI. That's simple. And then we pack it again for the results. Q star in X. Pack all Q. There you go. We probably need to pad that just in case there is not enough in the argument. So we pad that to match the 64 bits, so with zeros. And so 64 is 8 bytes, so we need 7 bytes padding.
Solar files from 1132 UTC.
7 byte padding so that we don't introduce an extra byte. And if you are the only one, we pad it to 8. There you go. So that's it for I'm missing a comma here, a quote. And that's it for the so now secret. Should we debug it? Secret needs to be safe. And so in the files key equals blah blah blah, and so let's place it here. Oh, not here. Debug. Did the best debug? What is that? debug key, and let's work it out. Missing likely in what then? That is it the end? Yes, it's the end. So they just made a mistake somewhere. There's not a clue here. I need a clue. What's wrong with me? So that's the if else. So there's an open one somewhere. This. I cannot see it. Probably in XOR because I just work on the XOR. No, it looks okay. Oh man. Make sure I try again. Or square bracket. So let's do it this way to see. Oh yes. Oh yes, there's a missing one in thread.
Building solar video clip.
Oh, the if terminal? No. Oh yes, of course. Yeah. Fail to query password permission. That's interesting. Tilde, and I got empty. Oh, you go. Oh, because it's in the cache, probably the password. I don't have access to the cache. Why don't I do twice Perl, pipe Perl? That's why. If you do a pipe, then yes, the pipe is not allowed to get the input of the, because it's focused. So, key ID, Michel. Authorization key, 2 characters, 1, 2, 3, 4 is the one that we saved before. Token is this one. Oh yes, I'm loading the keys here. From the environment. And how come I didn't say that before? It's funny. Oh, because that's the first time I use the environment here. I use the environment here, so it's looking for the thread key nonce to compute that. And here you go, yeah. So now I have a protection key, which is a little clover, and that may generate me the secret, which is that key. And when I say that key, that means it's, maybe I should do the safe so that if it's pipery, it's unsafe. Well, no, because it's dangerous. But I can do put the key in plain text. And back. And when you look at it, yeah, now it's asking me the password because I put 3 minutes. There's been more than 3 minutes. So 1, 2, 3, 4. And that's the key here. And so if I place another key, let's see if I do another key. UID-v4. And I will call it Gilles. So I put another key in the registry. And so this is not key, this is just a cipher version of the key. So no one can decrypt it unless it has the right password. And if I do want the key Gilles, so password for the key Gilles. So you see I never define any password anywhere. And so I create, the password is used on the fly to be able to generate the data protection key to decrypt the registry. And if I use the password, let's say 1, 2, 3, me.
UT 2068 done.
Then I have this key, which is different than the one we see above. Let's go back to the same version so that we have the little icon representing the key. It's easier to identify. And so that was here. So when you have the little icon behind the scene, you have a full 256 bit value. So if I do, here you go. So that's the little key, little key with that version of it. And so if we do, we can do a pawn on that, and you will know that it's totally safe. So if I do pawn key, and so that was the prefix, then the it value, then the key anonymous number, the range. Let's put S. And so if I do that here and define point, oh yes, because I didn't import it. So it's point. Oh, it's the SHA version that I need to to send. So that will be K, no, unpack hash of K hash SHA-1. It's a bit complicated. It's worth seeing that the key is safe. There you go. So 08 out of 876 value that has that prefix. And if you look at the key that we had above, go back? I don't know if we can go back. Up, no. But it was the same than before. The one, it was the little key with the key symbol. We can have that by doing save key. So now we will have both. And let's do point or not. So password, what is the use? We have 123 Sunny. It takes time because it's probably go to the database to look if the thing is point. Uh-oh. Waiting. Here you go. Oh, the key is different. Empty. I didn't get any record back. 500 error. My network has maybe problems here. There you go. Now it's okay. So you see it's the same. There you go. So now we have a system where we have key registers somewhere, and they are used to build secret on the fly. And there is absolutely no way anyone can reconstruct the key, because you have two factors for that one key. The first factor is the authentication token that is generated on the fly. That's this token here. And the second factor is the nonce used for generating the seed, which is this this token, the key there. So you need to have those two to be able to recompute that key, and that key does not belong to the dark web. So it's guaranteed to be safe. First, we also use more than the 64 character available, or even the 90 characters or 128 characters available with 7-bit, because we use the base 32. So we consider that every password that you tap, every passphrase that you tap, is a non-coded value, a binary uncoded value, and so we convert that to binary. That's why we have only 5 characters if we even type more, but those 5 characters are guaranteed to not be in a dictionary, because people don't use they don't use 32-bit character for their password, and technically we do. So it's like you can have emojis, you can have plenty of things in your password, but you type it normally on the keyboard. It's just like you have to know the basically either you know the base 32 code, or you don't care. It's just a matter of typing. Like if you want to type an emoji, you type with the character symbols, like the smiley is colon parenthesis, the heart is lower than 3, whatever. On a phone, it's a little bit tricky, but you don't need to type the exact things. It's in your brain. You need to have a smiley, you need to have a special character, you need to have all those things, and you can tap like a S for shift, you can tap a U for underscore, you can type a B for bold, you can tap I for italic. It's up to you to decide your coding scheme. As long as you have those meta characters, that change the behavior of the following characters. Like if I want to type like bonjour, and I want to make the G underscore, I can do that. And I want to have the O like bold, I can type that, you know. Or even I to type everything lowercase, and if I want to have a U uppercase, I do like uppercase are modifiers. And so, yeah, bold. If I want the N as italic, I can do I. Then if I want to have a smiley, I can put S smiley. So you can have those little clues for saying that there is a modifier for the next character. The idea is that you create enough entropy and length, even without a fancy keyboard, to have the equivalence to 32-bit per characters. Maybe not 32-bit because here it's 16-bit basically. You combine two characters, or even less, a little bit less. But you can do like a lot of things. It's like you can say U plus I plus B, so underscore bold italic for the B. And you can do even a display with colors. So you can say this N, I want to have it in color red. And so it's like you have your special password markdown language. And this makes it totally unbreakable without the need of fancy keyboard. And we can display, like we can have fun displaying it like in a graphical ways also if you guys want to. But it's a way of making strong password without the hardship of you know going through special characters and type of thing. You can have, for instance, special characters. You can have a name, like I want to type a % here. I can say it's special character. I use a dollar or what is available, and dollar %. Or and there I want to have the copyright symbol, so I can do dollar copyright, and that's just a way of making it very hard to guess, having that type of encoding. Then you can have yes, there you go. And for sure you can have the numbers. If the numbers are too complicated, you can even spell them like special number 2. So that's a way of being imaginative for you without the need of having difficulties to type it or hard time to memorize. People memorize more symbol easily than words because we are more visual. So that's why you have to have a graphical representation of your password in your brain. And then you type it, basically you translate this graphical representation of your password in your brain into text. And it can be any type of coding scheme that make it easy for you to type. So that's why my little 2 cents on passwords.